Paper chromatography. Chromatography is a separation technique, and paper chromatography can be used to separate and visualize the component of a mixture of dyes. In paper chromatography, you get a sheet of filter paper and you draw a line at the bottom using a pencil. This line is called the baseline or the start line. You use a pencil, not a pen, because pencil will not dissolve in the solvent, while a pen can contain dyes that can dissolve in the solvent and can affect your chromatography. After that, you start adding or spotting the different components or the different dyes on the start line. And if you have a mixture, you also add a spot of your mixture. The next step is to place the filter paper vertically into a beaker containing the solvent and make sure that the level of the solvent is below the starting line, so the dyes do not dissolve in the solvent. Cover the beaker and leave it until the solvent travels up the paper, but make sure it doesn't reach the end of the filter paper. The next step is to take your filter paper out and then mark the level of the solvent, and this is called the solvent front. You can now see that the different dyes have moved up the filter paper at different places, and if you have a mixture, the different components have been separated. So this is one spot for one component, and these are two spots for two different components in a mixture. Now we need to understand the principle of chromatography. So chromatography, as we said, is a separation technique. In chromatography, we have two phases, a mobile phase and a stationary phase. The mobile phase is the solvent you used, and it carries the soluble components of the mixture. The greater the solubility of the component and the solvent, the faster it moves through the filter paper. The stationary phase is the filter paper we used, and it slows the movement of the component attracted to it. The stronger the interaction, the slower the component moves. The separation here results of the balance between the components' interaction with the stationary phase and the mobile phase. So different components will have different solubility in the solvent and different attraction to the filter paper or to the stationary phase. This is why the different component will travel different distance through the filter paper. Paper chromatography can be used to identify the component of a mixture of dyes. This is through the calculation of what we call the RF value. In paper chromatography, we have the start line or the baseline, and we have the solvent front. We can calculate the RF value by dividing the distance moved by the spot, which is the distance between the start line and the center of the spot, and the distance moved by the solvent, which is the distance between the starting line and the solvent front. The RF value can be used to identify each component of a mixture. First of all, the RF value will differ depending on the solvent and the stationary phase. So even the same component will have different RF value if we use different solvents. However, if we use the exact same filter paper or the exact same stationary phase and the exact same solvent, then we're going to have the same RF value for the same component. So the substances contained in a mixture can have different RF value each component, and we can compare the RF value from each component with a reference value, and then we can identify the component of the mixture. If we have a sample or a mixture of different dyes, then each component will have a different spot. So that will give us the different spot, and each spot will represent one specific substance, like this one. And if we have a pure substance or a pure dye, then it will only give you one spot which represent that specific component. You can now compare the different components or the different RF value for the pure substances with the different component in a mixture to identify the different component that we have in that particular mixture.